Now, today we are talking about free fall. Free fall means like falling without um, air resistance. Okay. All right, so in a vacuum, you can create a vacuum chamber and you can obviously. Okay, so when something starts to fall, right? I just want to tell you that the speed initially is zero. And we learned previously, even if the speed is zero, then the acceleration due to gravity will always be there. That will cause, it to have a weight. So when the speed is zero, the acceleration is still 9.81 and the time has not started. So what happens is that after like 1 second, the speed. Walaikum salam, walaikum salam. Fatija, the other Fatija is not here. So after like 1 second, the speed becomes 9.81, which it's basically 0 plus 9.81 like that, right? So as it continues to fall, the thing is that the weight is still the same. The acceleration due to gravity is still the same. So in the second, it would be something like 9.81 plus 9.81. That I believe got to be 17 point something. Just a second, please.
Sir, what chapter is it? The same or different?
Yeah. So it's going to be like, 19.62.
Sir, is this the same chapter or different one?
So I cannot understand you.
Hello.
Yes. Speak again.
Is this the same chapter or we've started with a new one?
It's the same. Kinematics is not finished yet. Okay. So speaking of that, so in the third second, basically the weight stays the same, right? So every time you go in third second, it's going to keep on increasing by the same value because the acceleration will stay constant, right? So if you add like 19.62 to 9.81, so it is going to be 29.43, and it will keep on doing that until it basically falls to the ground, right? So nothing changes. So in this particular fall, the acceleration will always stay constant. But when we talk about when you fall in presence of air or any fluid, or that matter of fact, initially you have weight that is acting downwards. Okay. And the velocity 9.8. No. Soft one is that increases. It's not only like still there, but now little bit air resistance also increases. The reason is that air resistance, which is also known as drag for air, it increases its magnitude with increasing velocity. So if the velocity is higher, obviously the magnitude is going to be higher. like you can take your hand out, and when you're moving, like the car is like moving faster, you feel more air. But if car stops, you feel less air, right? Like that. So what happens is that because of this, now if you look at here, the weight is still there, but there's an opposing force of reaction as well. So overall, your acceleration reduces. So suppose it becomes 8. So now what happens is in the second, it's going to be 9.8 plus 8, which is basically 17.81. Now, if you notice, the speed has still increased, which means the weight that we're looking at, it's still the same, but air resistance will further go up. And because the air resistance getting bigger and bigger, which means that basically it's getting more balanced. Hence, the acceleration is getting smaller and smaller. So now in the third second, we'll get like 17.81 plus 4, which is 21.81. And eventually, it will reach a speed, like for this one, it reaches 21.81. And suppose at this speed, the weight becomes exactly equals to resistance. So weight is equal to resistance here. And now we should understand that then basically if weight becomes equal to resistance, then acceleration is zero because now the forces are balanced. So acceleration will become zero, and no matter what, till it falls, the speed is the same. It will stay the same because now there's no increase. And this value of speed is called the terminal velocity. Now let me write it down for you. So first step, we should understand that the weight acts downwards. Okay. When the object falls, it falls at acceleration due to gravity, right? Then we can say that as the speed increases, so does the opposing force of air resistance. And now we can say that at a point where air resistance and weight becomes equal, acceleration becomes zero as the forces are now balanced. Okay. So the object reaches a constant speed known as the terminal velocity. So you can just remember this, okay? Please write it down, it's very important. Okay. All right. Okay, Khatija squares. You guys understand Javeria and Ryan and Laiba,
Yes, sir.
Mohammed, Ahmed,
Yes, sir.
Ahmed Aziz.
Yes, sir.
बेटा तुम्हारी मुझे कंप्लेंट्स बहुत आ रही हैं क्यों क्या कर रहे हो तुम आज क्लास में तुमको मैं सीधा
In
करता
the
हूँ कल
in the practical class.
जी तुमको मैं कल सीधा करता हूँ सुहेल हमाद हाउ आर यू यू गाइस अंडरस्टैंड उमर वसाम या
Yes.
ओके हिबा ऑलराइट ओके वेरी गुड
Yes, sir.
now there's something I would like to tell you now and that is so the general graph for this is like it would cause the velocity to increase and then it will become like constant at some point, right? Where it becomes constant, this means this portion is the terminal velocity. Now, obviously, because the speed is basically there to make sure the reaction force is developed, right? So higher the speed, the reaction speed will be higher. Which means if you see two graphs, like one graph like this of another object, which has considerable lower terminal velocity, so you should understand that this object has more weight than this one. All right. The reason is that if you have smaller weight, then obviously you need smaller reaction force to balance it. And the smaller reaction force can easily be achieved at smaller value of velocity. Do you guys understand what I'm saying? So, what I'm saying is that an object with lesser weight will reach smaller terminal velocity as its weight will be quickly balanced by reaction, right? Do you guys understand this? But naturally, something heavy would, have the same thing. Now, if you try to, just drop two things on in a place where there's vacuum, obviously both things are going to fall together. The reason is, although they have different weights, but their acceleration due to gravity is the same. But in air resistance, what happens is that in air resistance depends on the velocity. So you have to reach a higher velocity for something heavier so that you balance that weight out. Is it clear, everybody? Any questions? Please let me know. Okay. So similarly, in this question,
Sir,
it
could
says,
you repeat the sorry, could you repeat the last statement?
so what I'm saying is that basically I've written it here that actually for something which is 800 newtons weight, right? And there's something which is 400 newton. So obviously, when both things fall, the 400 newton one is going to get balanced quickly. Do you understand? It will take less time. The reason why this is happening because air resistance causes is basically a cause of increasing velocity. Do you agree on this?
Yes.
So an object which has less weight will require less air resistance to balance it out. Do you agree? So it means it will also require a lower terminal velocity. It will have lower terminal velocity to do so. Do you understand my point? All right. Is there anything else that I can help you with? Okay. Now, The raindrop falls vertically from rest in air. The variation with time t of the speed of the raindrop is shown in the graph. It says which statement about the raindrop is correct. First of all, at point x, the raindrop has an acceleration of 9.81. That's not true. The reason is that it would have the same acceleration on the straight line, which is this. In your exam, you can just use your ruler to, draw the tangent. So till here, it is like constant, but now acceleration is decreasing. So that is absolutely wrong. At point Z, the force on the airdrop due to air resistance has reached its maximum value. So the acceleration of airdrop has reached its maximum value. No. At point Z, the force of raindrop due to air resistance has reached its maximum value. That is correct. But so the acceleration must be zero, not maximum. Otherwise, it cannot have constant velocity. So that's absolutely wrong again. So we can always say at constant velocity, you should always remember acceleration has to be zero. Then at point Z, the force due to air resistance is equal and opposite of the weight of the raindrop. So the speed of the raindrop is zero. No, the acceleration has to be zero, not the speed. So that's wrong. The resultant force on raindrop is less than resultant force at point X. Yes. Now it says the resultant force on raindrop at point Y is less than the resultant force of point X. That is correct, because you see, at this point, the weight is the same, resistance is much smaller. So obviously the resultant force is higher. But as it reaches the terminal velocity, the weight is the same, but the air resistance grows. So now the resistance, the basic resultant force is much lower. And that would be the answer. Do you guys understand this? So these sort of questions, unless you do not learn these 5 points, you won't be able to, answer them. So make sure that you read them very thoroughly and you take your time with them. Read every statement because they might, get you confused at any point. Anyway, can I go forward if you guys have no questions? Okay.
Yes.
Going to the next. The sphere falls from rest through air. The graph shows variation of time sphere velocity. Fine. Which diagram shows the forces acting on a sphere when it is vertically corresponding to point P? Now, point P, can somebody tell me if it is reached terminal velocity or not?
No.
No. So which diagram do you think is correct?
D.
D.
It would be C. That's correct. Why? This is when it reaches terminal velocity. Because they're equal. This is when it has no velocity. This is when the weight is obviously greater than this. So obviously there is some sort of acceleration. Acceleration is not equal to zero. In this one, probably parachute is open. So certainly the resistance increases. So that is the reason why it is like that. In a case, if this was D, it would cause it to decelerate. So if they had asked for this portion, I would have answered this. Do you guys understand? All right. I hope I made this clear. Please have a look at it, absorb this. Let me know if you have a question before I could go forward. Okay. Good going. Now, in the next question says that a stone of mass m falls from rest at top of the cliff of height h. Okay. Just before hitting the stone V, what is the average force of air resistance acting on the stone? So this is a very, very important question. Let me just explain it how. So we're going to just look at this. It says a stone of mass m falls from rest at top of cliff h. So there is a cliff which has a height h. And obviously, when it hits the c, the speed is some speed v, and initial speed is 0. And it says, what is the average force of air resistance acting on the stone during its fall? Okay. Now, we need to understand that the resultant force has to be equal to the weight minus the air resistance. Everybody agrees to this?
Yes.
This means that R, can we write it as this one? Can we do that, please? Would you guys mind? Right? Now think about this. We want to find this. We know that W is equal to mg, which is mass times acceleration due to gravity, and resultant force is ma. Now, if you look at the question itself, there is nothing that has a in it, so we need to remove that somehow, right? So what we see is we see v squared over 2gh, v squared over 2h, something like that. So what we can do is we can use SUVAT. This is h, initial velocity 0, final is v, acceleration is basically g, and oh my god, flu is killing me. Wait a second. Oh. Okay, all right. So now, speaking of this, then we can simply, find. Let's say this is a this is t. Anyway, so now t is not known, so we can use 2as equals to v square minus u square, and 2ah equals to v is v square. This is 0. So a would be v squared over 2h. You guys agree? Now you simply
Yes.
put it right into this equation. What you get r equals to mg minus m times v squared over 2h. Take m as common, so the air resistance is going to be g minus v squared over 2h. Which part is this? This is this. Do you guys understand? This is just a tricky question that I just wanted to solve for you. Okay. If you have any questions, please let me know. Anything you guys did not understand? Okay, yeah, everything is clear. Sultanat, do you understand this? Khadija squares, Ahmad,
Yes.
Great, Bad,
What?
and Laiba.
Why F equals W minus R? What is that?
Sorry, come on. Yes, yeah.
Yes, sir.
F equals W minus R.
Okay, all right. Now, then it says a rock of surface of Mars is projected vertically upwards the initial speed of this. The rock rises to height. This assume there's no atmosphere. What is the acceleration of free fall? Now, this is very simple. This is an SUVAT question I'm going to give you as homework. So you should be able to do it. I'm sure of that. Considering that I've taught you when to go up, when to go down. Okay. Now, acceleration of free fall near the surface of Mars. Okay. Please do not take, I'm just writing, please do not take G to be 9.81. That's only for Earth. You need to find it on Mars. So that's what you're looking for. Okay, so just make SUVAT in this question and then fill up everything else, what is given, and find acceleration. This is what you need to do in this question. Okay, so please make sure you do this. Anyway. Okay, I'm sorry. Now it says the skydiver jumps from a high altitude balloon. Explain briefly why acceleration of skydiver decreases with time. Who can tell me, please? Anyone who has the idea about that?
As the skydiver falls downwards, the air resistance increases.
Okay, so you're saying that as velocity increases, so
Yes.
does air resistance. Okay, what is the second point then?
This will reduce the acceleration.
Okay, so basically an opposing force of air resistance will reduce resultant force, thus air resistance, thus acceleration reduces. Is that clear, everyone? So please be concise. Writing in points is a plus, obviously, you know. Then why is it that at 9.81 is the start, the acceleration in the start is 9.8? Why?
Because of gravity.
Okay. Due to gravity, and that's all we want to write?
Gravity.
As the speed is 0. So with the speed, your acceleration reduces because air resistance increases. So you have to make sure that you understand that at the start of the jump, the speed is 0. Do you guys understand this?
Yes. Yes.
And it would be ideal if you
Yes.
write about the vertical speed, because obviously when you jump from a plane, obviously you will have some horizontal speed as well, but that doesn't really matter. Anyway, so they've given you the graph and they say determine the magnitude of acceleration of driver at this time, which is basically 6.0. Now what do we do? So you go on to 6.0, you pick this point and you might realize that this is not a straight line. And if it is not a straight line, then what you're going to do is you're going to make a tangent. The tangent is drawn by simply using your scale such that it only touches a single point. This is not exactly what I wanted to draw, but it should be something like this. Oh, not even this. Sorry. Something very precise. Okay, just bear with me here. Okay, like that. Oh no. Oh, where did I go? Sometimes it sucks. Okay, like that. And when you have drawn a tangent, you got to take 2 points on the tangent and then find the gradient, right? That is the reason why it is a 3-mark question. So speaking of this, then take the easiest points that you might see. And to me, you can take one of this point, which is 6 and obviously 20. So we're going to take this as 6 and 20. And you can take the other point as, I don't know. What should I take? I don't know. Okay, generally you should take a point that is far off. But if it's completely coinciding, that's good. 12 isn't coinciding really well. So if I take this as this one, which is almost like a straight line, I don't know. But I'll take 10 and 0, which is easier for me, 0 and 10. So now what you're going to do is just do 20 minus 10 divided by. So which equation I'm using? Y2 y1, x2 minus x1 to find the gradient. And then 6 minus 0. 10 divided by 6. Was that anyone? Ten divided by 6 is what? I don't know.
1.66.
1.67. Okay, 1.67 meters per second squared. All right, is this clear, everyone?
Yes.
So always draw a tangent on a curve, please, when you're finding a gradient. Now, then it says the skydiving equipment has total mass of this, calculate the total weight. So 90 times 9.81, what that might be. Yes, please.
880.
8,
82.9.
882.9. Okay, now I just want to tell you 882.9. Do not write this. Why you do not want to write this? Because the rule is that your answer should be in minimum significant figure one more than that. Because your minimum significant are 2, 2. So either your answer can be 880 or it could be 883. Nothing above, nothing below. Do you guys understand? Always make sure you do this. Now, okay, I said, look at my brain. It's not working. All right, anyway. Then says the accelerating force. So force that is causing is the resultant force. We have the mass and the acceleration we found was this one. So could you please find this?
150.
150.
I think.
Okay, 150 is the correct answer then. Then says user answer determine the resistive force. Now you see that basically the weight is down, the air resistance is upwards, and obviously the resultant force is 150. So resultant force is equal to weight minus the reaction. We want to find the resistance, so we want to do this. So 880 minus 150, and that would be 730, I think.
Yes.
730.
Yeah.
Yeah, 730. That would be the answer. Everybody understand this?
Yes.
Yes.
Good. Okay. Very nice. Very nice. Okay. All right. Now, the next thing we're going to do is basically the motion graphs. They're very simple as long as you learn the two rules. Okay. First rule is that you should always remember the gradient is also known as slope, and the symbol we use is m, and the gradient is found by y2 minus y1, x2 minus x1, like that. Now, if you have a line that is showing you it's going up, it means it has a positive gradient or a positive slope. If it is going down, it means it is a negative gradient. Now, a flat line, which is a horizontal one, it means the gradient is 0. If it's a slanted line, it means gradient is constant. If it is vertical line, obviously the gradient is maximum or infinity. Okay, is that clear, everyone? Whatever you want to call it.
Yes.
Okay, so if you see a line that is going upwards like this, it means that the gradient is increasing. Do you understand? The reason why it is increasing because it is going from a horizontal tangent to a vertical tangent. Do you guys understand this? If you see a line that is going like this or whatever, so you should understand that because it is going from a vertical line, which is maximum, to 0, it means that its gradient is decreasing. If you remember these rules, then there's nothing that can, go wrong when you're solving graphs. Okay. All right. Please write this down on your notes. And when you're ready, we will go to the next part. All right. Pretty cool. Huh? Okay. Okay, next. I'm sorry. Now, when you look at displacement time graph, you should always remember for displacement time graph, the gradient. And we want to comment on okay. We want to comment. Wait, can you hear me? Okay, sorry. You guys can hear me now?
Yes.
Yes.
Okay, I'm sorry. For a moment,
Yes.
I got disconnected. I don't know why. All right, anyway. So suppose this graph is given to you and they want you to find the gradient of, like, they want to comment on AB and then BC and then CD and then DE and then EF. Okay. So first of all, if you look at AB, it's basically going up and it's a straight line, slanted line. So it means it is positive, constant velocity. Do you guys understand this? If they show you a line which is like this, it is a flat line. It means it is zero velocity because the gradient is zero. If you look at line CD, you can make two tangents. You can make a tangent here, you can make a tangent here. So you realize that basically it's going from a flat line. It's going from a flat line to a sort of vertical one. So it means that the velocity is positive because it's going up and it is increasing. Okay. Now, if you look at this one, you might realize it's D and it's like this. So it's basically going from a vertical to horizontal one, which means that this is like still positive because the arrow is still up, but it is decreasing velocity. Positive means that it's going forward or whatever direction you've taken as positive. But in line EF, it's going down. And you might realize that basically EF is basically negative because it's going down. Because it's a straight line, so it is negative and it's constant velocity. It means it is going in the opposite direction with the constant value. Is that clear, everyone? Any questions here? Okay.
Just
All right. Suhail, Ahmad, Ayan, Javeria, Fatija S and Fatija Irfan. Okay, good. Now, if you go on to the next one, remember velocity time graphs have the gradient as acceleration. Okay. So now in this graph, we're going to comment two things. We're going to comment on the velocity as well as we're going to comment on the acceleration. AB, BC, CD, DE, and EF. Okay. So for AB, if you realize this, who's going to tell me what is happening to acceleration, please?
Constant.
It is constant, right? And it is
Positive.
positive. Very good. It is positive constant acceleration, right? if you realize this, the line AB is going up. If the arrow is going up, it means that the y-axis values are going up, which means we can say velocity is increasing, right? Okay. Now I want, okay, Hamad. Hamad, can you please tell me what is happening to BC? In terms of acceleration first.
No acceleration.
It has no acceleration?
Yeah.
It has zero acceleration. That's correct. And what is happening to the velocity then? Javeria, can you please tell me that? Velocity is? It's basically staying at the same point, right? Throughout this time, which means it is constant. And I told you at zero acceleration, velocity is always constant. Okay, Javeria, is that clear? Okay. Now, next person. Umar. Umar, can you please tell me what is happening at CD? Let me draw tangents for you.
Acceleration is increasing.
Okay,
Positive.
so you have positive acceleration and it is increasing. Okay. And Laiba, what is happening to the velocity?
Increasing.
Velocity is increasing. Very good. All right. Now, next is let me see, Hiba. Hiba, can you please tell me what is happening in D? Hiba.
Yes, sir.
Okay, can you tell me what is happening in D? Acceleration, please.
It becomes 0.
No, it does become 0, but you want to tell me whether it's decreasing or increasing or staying constant.
Sir, at B or D?
DE, the total
Decreasing.
DE. It is decreasing. Yeah, it is decreasing acceleration. Okay.
Yes, sir. I thought you were talking.
No. Okay, then Saltanat, can you please tell me what is happening to the velocity here?
Velocity is also, the velocity is increasing.
Velocity is increasing. Very good. Although it's increasing slowly, but it is increasing, right? Okay. Unless this arrow doesn't go down, like in this one, then you will write decreasing only. Okay, now, next one is Ayan. Can you please tell me what is happening at acceleration? EF?
Yeah, negative decreasing acceleration.
Negative and constant.
Yeah, constant.
It's basically constant deceleration. Okay. And then Khatija, Irfan, can you please tell me what is happening to the velocity?
It's decreasing.
It is decreasing. The reason it is decreasing because the line is going down, and you should always remember that. Now, if you keep on the rules with you, obviously you will never fail in interpreting any graph that they throw at you. All right, you can write it down, please. And then we're gonna go forward. Hello, Dania, terribly late. That's not good. Anyway. Now, considering this, we're going to go for the first question. So the first question is pretty easy. It says a skydiver jumps from airplane, falls vertically through air. Which graph shows the variation of time? Anybody can tell me which is the variation, correct? Which variation is correct?
C.
It has to be C. Very good. Because obviously it is decreasing acceleration, as we know. Very easy. Then says a stone is dropped from tall building. Now you see this graph, this question and this question are basically the same, but they're talking about distance time graph, right? So it says so a stone is dropped And now it says it falls through the dashed line that they've shown, and a second stone with the same dimension but smaller mass. So I told you when the mass is smaller, which means weight is smaller, will it have a higher terminal velocity or lower terminal velocity? Anyone?
Lower.
Lower.
Lower. Very good. If it has a lower terminal velocity, which path do you think would be correct?
So B.
B. What is the gradient of distance time? What does the slope represent? Anyone? What
Sir,
is
it's
the
C.
Velocity.
Speed.
velocity? So if somebody who's told me B, why is B wrong? Because the gradient is higher, right? If the gradient is higher, don't you think the velocity is going to be higher in both A and B? So that's absolutely wrong. Do you guys understand? So it's either C or D, because if the gradient is lower, it means the velocity is lower. Then why it is not D and it is C? Anyone? Let me comment.
Is it C then?
It is C because obviously the speed is going to increase till it becomes constant. It cannot be constant from the very first time. So that's wrong. Do you guys understand this?
Yes, sir.
Okay.
What is repeat what you said about D?
So here D shows that it is constant from the very first second. Is it possible? It will accelerate down, no? So it has to increase the speed, no?
Yeah.
So it's not possible that it's a straight line. Straight line shows it's constant, which means the moment you drop, it reaches terminal velocity. That's not true. That cannot happen with anything, really. Do you get my point? Okay. All right. Now, this sort of questions will be rampant, and I'd like to discuss them with you, but some of them I'm going to give you as assignment. So I'll discuss. Okay, I'm going to give this one as your as homework because this is simpler. But I'm going to discuss basically this one. So it says a ball rolls in a straight line up a ramp. So it's going up a ramp in a straight line and then down the ramp on the original path, which graph shows. So obviously when it is going up, it will have a certain velocity, which is non-zero, right? And when it reaches the maximum height, its velocity is going to be zero. You guys agree?
Yes.
Which two
Yes.
graphs show that? The first part, please.
C.
A and D.
A and
A.
D. So
Sir,
it's
I think
automatically,
it's D.
yeah. So A, C, and B are wrong, right? So we're gonna cut it off. But then when it falls down, its initial velocity is zero, and now it will have some velocity again. But now, if this was the positive direction, now it will fall in the negative direction because it's a vector quantity, right? So which do you think is correct then? A or D?
A.
A.
Because after reaching zero, it should go to the negative direction. In this one, it is going again the positive direction, which is not correct. Do you guys understand this? The above
Yes.
question is exactly the same. You just need to see when it will have higher velocity, higher acceleration, when it will have lower one. And obviously you can interpret it through that. So I leave that to you. Now, this one. So a mass on the end of a string bounces up and down is shown after being released at time t0, which graph shows how the velocity varies with time. So it says the mass on a spring, it goes up and down, which means normally the spring would be here. That's what this is the equilibrium point. At equilibrium, you should understand the velocity is always maximum because when either it goes up, you compress the string, which means now velocity will be 0 at maximum point. It will have highest potential energy. And again, when it goes down, velocity will be 0 and it will have again high, but it will be in opposite direction, right? So when the distance is down, it is right here. Do you think the velocity will be maximum or 0? When you're at the maximum position, when it has the greatest potential energy and no kinetic energy, what do you think the velocity would be?
0.
0.
Zero.
Okay. So that means this is absolutely wrong, right? Okay, now see this. When the displacement is 0, which means it is at equilibrium position, velocity will be highest or lowest?
So highest.
Highest, which means either this or this is going to be right, but this is wrong. So you see, I'm eliminating everything one by one. Now, when it moves to the highest
Sir,
point
could you
again,
please repeat this?
sorry?
Could you please repeat this?
Yes. If you see this point, here the distance displacement is 0. It means it is right here. Do you understand?
Yes.
So at this point, it has no potential energy. So all its energy is in kinetic. So it will have highest velocity, right?
Yes.
If it is the highest velocity, then which two graphs show that? At this point, either this graph or this graph. This is 0 velocity. That's why I cancelled it out. Do you understand?
Okay.
Now, when it reaches the highest up, like here, its potential energy is maximum. So kinetic energy has to be 0. So which graph shows that? Both of them, right? 0, 0. You agree?
Yes.
Again, when it reaches, like it's now going back. Now it's going back here. Here it was going up. Here it's going back. So what do you think would be the velocity at this point? Maximum, right? But in the opposite direction, because now it's going the downward position. So which graph should I choose? The positive one or the bottom one?
So A,
A.
जिसमें negative जा रही है.
A, because this shows that the velocity is always up. That's not true. It cannot be always up because it's going down, up, then down, then up. Do you guys understand this? So you just need to, carefully do that. All right. Now, okay, any questions here? Please let me know. Okay. Now going to the next one, please. The last one I'm going to leave it to you, but this one I want to do. So this is homework. Then this one I'm going to do. It says there's a quantity and there's a time. We don't know what that is. And which event could be best represented by the graph. So we need to look at this. It says the acceleration of firework rising to maximum height and then falling to the ground. Okay. So definitely if it's going up, the acceleration how is it the acceleration is reducing? Can acceleration reduce in this case?
No.
No.
So this is probably not correct, but I'm still going to leave it on suspicion, right? I'm not sure about it. All right, let's look at a better answer. Okay, sorry. All right, now. That says the acceleration of skydiver leaving an aircraft. Okay, so if something is falling, do you think the acceleration reduces? And acceleration reduces till it reaches terminal velocity, right? Don't you think the acceleration is reducing and it is becoming 0? So when it is becoming 0 at this is the terminal velocity. Do you guys agree?
Yes.
Okay, so it means acceleration of skydiver leaving an aircraft falling. Till this, I'm sure that this could be the graph. Then Opening a parachute. What would opening a parachute do? It would slow down the diver, no? And
Yes.
slowing down means the air resistance is going to be higher than the weight, which means then it should be negative acceleration. It just shows negative acceleration. So that is also falling in line. And then falling to the ground. So when it reaches negative acceleration, again, the velocity is going to reduce, air resistance will come back to a balancing factor, and now it will just become 0. Again, it will reach a new terminal velocity. So I think this could be our answer. Is that clear, everyone? So I'm just trying to
Yes.
dissect. Then it says the speed of javelin as it leaves the athlete hand falls and sinks into the ground. If it leaves the javelin's hand, so it will have speed, but it will slow down. So speed is going to slow down. So it should show deceleration. Why is it showing decreasing acceleration? That's not true. The speed of high jump athlete leaving the ground and jumping over a bar and descending to the ground. So speed of high jump. So she jumps, okay, up. The acceleration would be constant because that's acceleration due to gravity. So that is also not correct. So in my opinion, this would be the answer. Why this I put it as a question mark, because the first part seems that okay, the acceleration is going to reduce because of the air resistance, but when it is going to fall down, it cannot be negative acceleration because acceleration will always be in the same direction, which is downwards. It's basically slowing it downwards, but it has two directions. It is positive one time and negative, so it can't be true because acceleration is just in one direction when you're looking at it vertically, so that would be wrong. Is that clear? All right. Okay. All right. Now, you guys gonna do this as homework. You're also going to do this one as homework. But if you still feel difficulty, this is a star question. Do discuss it later on. And obviously this one as a homework as well. So I've given a lot of questions to practice. And we are going to start from here tomorrow. All right. If you guys have still any other questions, try to do this one on your own, though this is easy. But basically, this one I'm giving you as homework, but actually I'm gonna solve this question with you people, okay, tomorrow. All right. If you guys have any other questions, do let me know. Okay. I will see you then. Have a great day. Bye.